Hello dear students, hope you have done good in your examination. After the last online half-yearly examination, this is our first class and in today's class we are bringing the lesson electricity, and in electricity today's topic to discuss is electrical energy and electrical power. What is energy and what is power? We have learned it in our previous classes. In the lower section in class 7, 8, 9, etc. we have discussed many things about energy and power. Energy is the ability to do work and power is the rate of consumption of energy or rate of doing work. Now, the same concept of energy and power we shall bring it today in the field of electricity. Since electrical energy is capable of doing work, so electricity is a form of energy and that energy is called as electrical energy. And since electrical energy is capable of doing work, therefore definitely there is a rate of doing work as well. And that rate of doing work of electrical energy is called as electrical power. In this today's topic, we will be discussing what is electrical energy, how it is calculated, as well as what is electrical power and how it is derived or how it is calculated, what are their SI units. So let us directly come back to today's lesson, and first we are discussing electrical energy. To understand this concept of electrical energy, let us assume an electric circuit, what we have already discussed before your online half-yearly examinations. Let us consider an electric circuit, and through this circuit Q amount of charge is flowing. That is capital Q amount of charges flowing through the circuit due to application of a potential difference of V. That is why this amount of capital Q charge is flowing through this circuit, because you are applying a potential difference of V. Under that condition, what we will get, the electrical work done by electricity in this circuit will be is equal to potential difference applied into the amount of charge. That is symbolically, if we assume electrical work has to be capital W, potential difference is V and the charge is Q. So mathematically, electrical work is equal to potential difference into charge, means W is equal to V into Q. In the previous classes, we have learned what is potential difference. There we come to know potential difference is the amount of work done in bringing a unit positive charge from one particular distance to another within an electric field. That is from infinite distance to a particular point with the electric field. So symbolically we got V is equal to W by Q. In the previous class we have come to know about the potential difference or electric potential. So electric potential is the amount of work done, that is W, in bringing a unit positive charge from infinity distance to a particular point within an electric field. That is to say that V is equal to W by Q. Mathematically we have learned it before. So let us write it here. If it is V, that is potential, is equal to W by Q. This is the relation we got in our previous classes. Now if we assume this is the formula, V is equal to W by Q, from here definitely we will get therefore W is equal to V into Q, and that is we are writing here, that is W is equal to V into Q. W is equal to V into Q. So this is the mathematical relation we are getting. Now if this is the mathematical relation, W is equal to V into Q, then another thing we can make it, that is V into IT. Why? Because Q means what? Q is the charge. So charge is equal to I into T. That is current into time. Why it is? It is because I is equal to, again you have to go back, I means current is equal to Q by T. That is current is equal to charge divided by time. If current is equal to charge divided by time, definitely then Q is equal to I into T. Now if Q is equal to I into T, then in place of this Q we can place the value of I into T. So it will be W is equal to VQ, means W is equal to V into IT. In place of Q we are placing this value. So ultimately we will get therefore work done is equal to V into I into T. Multiplying this. So W is equal to V into I into T. What does it mean? It means that means the work done is equal to potential difference into current into time. So we have written it there. So what is the work done by electric current? Electric current has done an amount of work, and how can we calculate it? We can calculate it by multiplying potential difference into the current in the circuit into the time. That is how much time the current is there in the circuit. So that is the first definition we are getting, the first mathematical representation, how electrical energy or electrical work can be calculated. So as you recall, that is W is equal to V into I into T. W is equal to V into I into T. This is a one very important formula that will be needed to do so many numerical problems in this lesson. Now, since we have got that W is equal to V into I into T, we are representing it W is equal to V into I into T. Now, another thing is that W is equal to I into R into I into T. How it is? So, let us again discuss it. We have here W is equal to VI, W is equal to V into I into T. This is the relation. But what is V? What is V? V is equal to I into R. From where did we get? We get it from Ohm's law. That is V is equal to I into R. So in place of V we can write I into R. Then you will get again I into T. So if we multiply we get I into I. So it will be I square R into T. So this is the calculation. And from this calculation we can therefore get that what W is equal to V into I into T. Ultimately we will get W is equal to I square RT. So this is the second relation with the help of which we can measure the amount of electrical energy or electrical work done by electric current in a circuit. So these are the two mathematical formula to calculate the electrical work. So I repeat, the first formula was W is equal to V into I into T, and second formula W equal to I square into R into T. So that will be W means work done is equal to square of the current into the resistance of the wire in the circuit into the time. So by using these two formulae we can calculate the amount of work done by electrical energy, or that is the amount of work done by electric current in a circuit. Now what will be the units of electrical energy? What will be the unit? To measure anything, a physical quantity is to be measured in science. And if you need to measure it, definitely you need a unit. Without using unit, you cannot measure anything. So if you want to measure the electrical work or electrical energy, obviously you have to use a unit. So what will be that unit? Standard International Unit, also called as SI unit. So the SI unit of electrical energy will be, SI unit of electrical energy or electrical work will be the SI unit of potential difference V into SI unit of current into SI unit of time. That is to say that SI unit of electrical energy is equal to SI unit of electric potential is what? Volt. SI unit of current is what? Ampere. And SI unit of time is what? Second. So SI unit of electrical energy is volt into ampere into second. Now what is volt? Volt is equal to joule per coulomb. Joule per coulomb is called as a volt. We have discussed it in our previous classes. Then what is ampere? Ampere is coulomb per second. That is also we have discussed in our previous class. And this is second. Now you can see in this equation you can cancel coulomb into coulomb. You can cancel second into second. And finally what will remain? Only joule. So ultimately SI unit of electrical energy will be joule. That is to say that work or energy both are calculated in terms of joule. So an electrical energy is also calculated in terms of joule, and this is SI unit. But in practical condition, commercially when electrical energy is measured, it is never measured in terms of joule, but it is measured in terms of a different unit, what is called as kilowatt hour. So let us see what is kilowatt hour. So but it is given commercial unit of electrical energy is different one. It is not joule. Then what it is? It is kilowatt hour, and it is represented as kWh, kilowatt hour. So what is 1 kilowatt hour? 1 kilowatt hour means 1 kilowatt hour, that is equal to 1 kilowatt into 1 hour. It means that if you are using a power 1 kilowatt and the time, how long you are using the electric current for 1 hour, then this will be 1 kilowatt into 1 hour. If we multiply these two things, then we will get it is 1 kilowatt hour. Now if we simplify it, 1 kilowatt is equal to 1000 watt and 1 hour is equal to 3600 second. Why? Because what is the SI unit of power and second is the SI unit of time. We cannot use hour in this measurement. We cannot use kilowatt in this measurement. we have to use only the SI unit. So 1 kilowatt is equal to 1000 watt and 1 hour is equal to 3600 second. If we multiply, we will get this is 36, then 5 zeros, watt into second. So it will be 3.6 into 10 to the power 6 joule, because watt into second is equal to joule. So what is 1 kilowatt hour? 1 kilowatt hour is nothing but 3.6 into 10 to the power 6 joule. So this is how electrical energy can be calculated, and this is how the unit of measurement for electrical energy has been used. In terms of SI unit it is joule, and in terms of commercial use it is kilowatt hour. So what we have learned here, we have learned two mathematical formulae, that is, one is W is equal to V into I into T, and the second is W is equal to I square RT. So we can write therefore W is equal to VIT, again W is equal to I square RT. So we can collectively write W is equal to VIT is equal to I square RT. After this, let us come back to electrical power. So what is electric power? So power is the rate of doing work or rate of consumption of energy. So electrical power is the rate of consumption of electrical energy. How much electrical energy we are consuming in a given time. If we get the ratio of this, then we will get electrical energy, that is power. So what is electric power? Mathematically we can write electric power is therefore electrical energy divided by time. So what is the unit of electrical energy? We have already got unit of electrical energy is joule. So I have written in joule divided by time, time is second. So joule per second is called as watt. Joule per second is what? It is called as watt. We have already learned it. So we have got that electrical power is calculated in terms of watt. Now watt is a very small unit of power. In the field of electricity, when we are commercially using electric current, 1 watt, 2 watt, etc. are very small units, and therefore it is not convenient to use such small units for measurement, and therefore they use a bigger unit. What is that bigger unit? 1 kilowatt. So what is 1 kilowatt? 1000 watt, when we combine together, it makes it 1 kilowatt. So that is to say that 1000 watt is equal to 1 kilowatt and can be written as kW. So what is 1 kilowatt? 1 kilowatt is equal to 1000 watt. That is equal to 1000 joule per second, or we can write it as 1 kilojoule per second. So this is how 1 kilowatt can be represented in the different ways. Now interestingly, already we have come to know that work or energy, that is equal to V into I into T. Yes, work or energy is equal to V into I into T. This we are writing. Work or energy, electrical work or electrical energy is VIT. So electrical power therefore will be work done, or energy divided by time, means energy divided by time means VIT divided by T. Because VIT is the energy and T is the time, so energy by time is power. So electrical power must be VIT by T. Now cancelling T and T, you will get therefore electric power is equal to V into I. So therefore electric power is what? P is equal to V into I. So this is the first formula to calculate electrical power. So how can we calculate electric power? Power is equal to voltage into current. That is P is equal to V into I. V for potential difference or voltage into current, that is I. So this is the first representation how electrical power can be calculated. Again, P is equal to VI. From this is the formula. This formula we are rewriting here. P is equal to VI. Now, if P is equal to VI, we can write P is equal to V into V by R. Why? Because I is equal to V by R. How did we get it? We get it from Ohm's law. Since V is equal to IR, V is equal to IR, therefore I is equal to V by R. So in place of I, we are writing V by R. So P is equal to V into V by R. So P is equal to V square by R. This is the second representation. This is to say that electric power can be calculated by different methods. The first mathematical formula to calculate electric power is P is equal to V into I, and the second formula we are getting P is equal to V square by R. So if you have voltage and current, you can measure electric current, and here you can measure electric current when you have voltage and resistance. So power of the electricity is always equal to square of the potential difference divided by resistance of the conductor. Similarly, P is equal to VI, same formula we are writing, P is equal to VI, P is equal to VI. Here we are adding P is equal to VI. Then P is equal to I into R into I. Why? Because V is equal to IR. Why V is equal to IR? Already we have got from Ohm's law, V is equal to IR. If V is equal to IR, so we are placing V is equal to IR, then I. So ultimately you will get P is equal to I square into R. That is, you can measure electric power by third process, and this is if you have electric current and resistance but no potential difference, then you can also measure P is equal to I square into R. Means power is equal to square of the current into the resistance of the wire present inside the electrical circuit. So we have therefore got that electric power can be calculated by three different formulas, and these three different formulas, first one is P is equal to VI, second is P is equal to V square by R, and the third P equal to I square into R, third. So by combining these three we can write, since all the left hand side has P, P and P, we can write P is equal to VI into VI is equal to V square by R is equal to I square into R. So this is how in this lesson we have understood what is electrical energy, what is electrical power, how electrical energy and electrical power can be calculated, and you have got some mathematical formulas. All these formulas are very important. In the later part of this lesson, in the exercise part, we will get so many numerical problems. To solve those numerical problems, we will have to use those mathematical formulae. So I request you all to go through this chapter very nicely. Thank you. We shall meet again.